So picture this. It's the summer of 2025, and astronomers spot something incredible. Just a faint smudge of light, moving against the backdrop of stars, but on a path that could only mean one thing. This thing was not from around here. An object from a totally different star system was passing right through our cosmic neighborhood, and you better believe it kicked off a massive global investigation.
Okay, so let's get right into it. The second this was confirmed, this one question became the central mystery for pretty much every astronomer on the planet. What is it? An asteroid? A comet? Something else entirely? The single question started a worldwide race against the clock, a mission to learn absolutely everything we could before this visitor from the void vanished forever.
So let's start at the beginning. What exactly makes this visitor so incredibly special? Well, it all comes down to its origin story, a story that started light years and light years away from us. The key phrase you gotta know here is interstellar object, and it's basically just a tourist in our solar system. Unlike our planets or our local comets, which are kind of on a leash held in orbit by the sun's gravity, these objects are totally different. They follow what's called a hyperbolic trajectory. In plain English, that just means they come screaming in, whip around the sun, and then shoot right back out into deep space, never ever to return. And just how rare is this? Well, let me put it this way. This object, which they named 3I/Atlas, is only the third confirmed interstellar visitor we have ever detected. That's it, just 3. It's following in the footsteps of that bizarre cigar-shaped object Oumuamua back in 2017, and the more normal-looking comet Borisov in 2019. So yeah, being only the third of its kind, you can see why this was an absolutely unmissable opportunity for science. So with only 2 previous examples to go on, you can just imagine the scramble when 3I Atlas was spotted. It was like a fire alarm went off in the astronomy world. A massive, coordinated scientific chase began, pulling in telescopes and scientists from all over the globe. And the discovery itself unfolded with incredible speed. It turns out astronomers had actually photographed it a month earlier without even knowing it. It was basically hiding in plain sight like a needle in a haystack against the super dense star fields of the Milky Way. Then, bam, July 1st, 2025, the Atlas survey in Chile makes the official discovery. And get this, within 24 hours, observatories all over the world, from the huge professional ones to amateur astronomers in their backyards, confirmed it had this faint glow around it. This wasn't just a rock, it was an active comet. The chase was on. Now that initial question, asteroid or comet, was absolutely crucial. You see, an asteroid is mostly just a chunk of rock, kind of a passive traveler. But a comet is an icy body that literally comes alive as it gets close to the sun. The heat makes its ice vaporize, creating that glowing atmosphere called a coma and a tail. And that outgassing is so important because it gives us a direct sample of the stuff it's made of, a little chemical taste of its home star system. And the evidence just started piling up fast. Observations showed that faint coma, check. They saw the beginnings of a tail, check. Its trajectory was definitively hyperbolic, meaning it wasn't from around here, check. And the smoking gun, as it got closer and closer to the sun, it got more and more active. All that meant one thing. We weren't just watching some dead rock fly by. We were witnessing a dynamic, active messenger from a whole other star system.
Okay, so we know it's a comet. The next phase? Basically dissecting this thing from millions and millions of kilometers away. Scientists aimed the world's most powerful telescopes, we're talking Hubble and the James Webb Space Telescope, to figure out the anatomy of this interstellar interloper. Now this is where the scale of this thing gets kinda wild. The solid core, the nucleus, is actually pretty tiny, just a few kilometers across. But its coma, that atmosphere of gas and dust, it was enormous. Just look at this. The carbon dioxide part of the coma alone was measured at 700,000 kilometers in diameter. Let that sink in. That is almost double the entire distance from the Earth to the moon. A tiny little icy rock was creating an atmosphere of absolutely immense proportions. But the most exciting part wasn't its size, it was its substance. By analyzing the light coming off the comet's coma, astronomers could literally read its chemical fingerprint. And that gave us our first real taste of the building blocks of planets from around another star. And what they found was fascinating. The James Webb Space Telescope spotted something really unusual. Take a look at this chart. See that first bar? The comet was incredibly rich in carbon dioxide gas, way more CO2 than water. Now, that's basically the opposite of what we usually see in comets from our own solar system. It's a huge clue that this object probably formed in a much, much colder part of its home star system, telling us just how different planetary nurseries can be across the galaxy. All right, so a discovery this strange and exciting, well, it didn't just grab the attention of scientists. As you can probably guess, with any mysterious visitor from the stars, it also sparked a whole lot of public speculation. And it didn't take long. Just a couple of weeks after the discovery, a paper popped up on the Science preprint server archive asking this exact question. It suggested that some of the comet's traits seemed anomalous and didn't really fit a natural explanation. It even explored the very speculative idea that it could be some kind of extraterrestrial technology. And that idea, especially after the whole mystery surrounding Oumuamua, really caught fire with the public. But as the global scientific community pointed their best instruments at this thing, the hard data started telling a very different story. The paper claimed there was a lack of identifiable chemicals, but as you can see, the Webb telescope found a whole cocktail of comet gases. It questioned the trajectory as being improbable, but once statisticians ran the numbers, it turned out to be perfectly consistent with a natural object. And that claim of a large size? Well, Hubble's super sharp vision confirmed the nucleus was actually pretty small, a totally normal size for a comet. So while all that speculation was definitely fascinating, the overwhelming scientific consensus, built on a mountain of data from observatories all over the world, is that 3I/Atlas is exactly what it looks like, a completely natural comet, just one that happens to be a visitor from a very, very long way away. And honestly, that's what makes it truly profound, not as some piece of fiction, but as a fact. This object is a genuine piece of another solar system, delivered right to our cosmic doorstep for us to study. An article in IFL Science put it absolutely perfectly. They called the comet a time capsule from another part of our galaxy and another age of the universe. Just think about that. It may have been traveling for billions of years, a totally pristine relic from the time when planets were just starting to form around its parent star. So at the end of the day, why does all of this really matter? Because by studying 3I/Atlas, we get a direct sample of the raw ingredients that build planets in another star system. This helps us figure out if our solar system is typical or if we're some kind of cosmic oddball. It helps us fine-tune our theories about how all planets are built, and it even tells us a little something about the vast empty space between stars that this object called home for eons. Right now, 3I/Atlas is already heading away from our sun, destined to continue its lonely journey through the Milky Way. Its brief visit has given us an absolutely unprecedented peek into another corner of the cosmos. And it just makes you wonder, doesn't it? This one little comet traveled for maybe billions of years to pay us a visit. What else is out there, just waiting for us to find it?